Picture this, a silent, endless expanse where stars are born, live and die, all within the blink of an eye on a cosmic scale. Out there, in the infinite darkness, galaxies drift like colossal ships on an invisible sea, their paths sometimes crossing in a dance that lasts billions of years. But this dance is no gentle waltz. It's a collision so powerful, it reshapes the very fabric of the universe. Galaxies, those vast collections of stars, gas, and dark matter, don't just pass by each other. They collide, merge, and sometimes one devours the other in a phenomenon known as galactic cannibalism. It's a process as beautiful as it is destructive, where the universe's largest structures are forged in chaos. Tonight, we'll take you on a journey through the cosmos to explore this mysterious and awe-inspiring event. By the end, you'll see the universe not as a static backdrop, but as a dynamic, ever-changing stage where galaxies are both the actors and the architects of their own fate. So, where are you joining us from, and what time is it there? Let's dive into the vastness of space together and uncover the secrets of galactic cannibalism. Now, let's take a step back in time, way back, to the very beginnings of galaxies themselves. Imagine the early universe, not as the star-filled expanse we know today, but as a swirling, chaotic sea of gas and dust. This was a time before stars, before planets, before even the faintest glimmer of light. In this primordial soup, tiny fluctuations in density began to ripple through the cosmos. These ripples, born from the aftermath of the Big Bang, were the seeds of everything we see today. Over millions and billions of years, gravity took hold, pulling these dense regions of gas and dust closer together. Slowly, almost imperceptibly, the first galaxies began to take shape. At first, these galaxies were small and irregular, mere clumps of matter struggling to hold themselves together. But as time went on, they grew. Gas clouds collapsed under their own weight, igniting the first stars and lighting up the darkness. These early galaxies were the building blocks of the universe, the first steps in a cosmic dance that would eventually lead to the majestic spirals and vast ellipticals we see today. But how did these galaxies evolve into the intricate structures we observe now? The answer lies in their interactions. Galaxies didn't form in isolation. They were born into a universe teeming with neighbors, each one tugging and pulling on the others through the invisible force of gravity. Over time, these interactions, sometimes gentle, sometimes violent, shaped the galaxies into the diverse forms we recognize today. Some grew into sprawling spirals, their arms stretching out like cosmic pinwheels. Others became dense, elliptical giants, packed with stars and shrouded in mystery. This process of galaxy formation wasn't just a one-time event. It's an ongoing story, a tale that continues to unfold even now, and it's this story that sets the stage for the dramatic collisions we'll explore next. Because as galaxies grow and evolve, their paths inevitably cross, leading to some of the most spectacular events in the universe. So, as we move forward, keep in mind that every galaxy you see, every spiral, every elliptical, every irregular cluster of stars, has a history, a story that began in the swirling chaos of the early universe. And it's these stories that make the collisions we're about to explore so fascinating. Now, let's turn our gaze to the grand stage of the cosmos, where galaxies don't just exist in isolation. They interact, they collide, and they merge in a breathtaking cosmic dance. Picture this: two galaxies, each containing hundreds of billions of stars, slowly drawn together by the invisible threads of gravity. This isn't a sudden crash or a violent explosion, but a slow, deliberate process that unfolds over billions of years. It's a dance of immense scale and beauty, where gravity is the choreographer, guiding every move with precision and grace. As these galaxies approach one another, their gravitational forces begin to tug and pull, distorting their shapes. Stars, gas, and dust are stretched into long, flowing streams, creating intricate patterns that resemble cosmic ribbons. These tidal tails, as they are called, are one of the most striking features of galactic collisions, a testament to the immense forces at play. Yet, despite the chaos, the dance is surprisingly gentle. Stars within these galaxies are so far apart that they rarely collide. Instead, they glide past one another, their paths altered but their existence largely undisturbed. Over time, the galaxies draw closer, their gravitational embrace growing stronger. Gas clouds within them collide and compress, triggering bursts of star formation. These starburst regions light up the darkness, creating brilliant pockets of new stars that shine with incredible intensity. It's a moment of creation amidst the chaos, a reminder that even in the vastness of space, beauty can emerge from destruction. Eventually, the galaxies merge, their individual identities blending into one. The result is often a new, larger galaxy, its shape and structure forever changed by the encounter. Some become elliptical galaxies, smooth and featureless, while others retain traces of their spiral origins, their arms twisted and warped by the collision. This process isn't just a one-time event, it's a fundamental part of how galaxies evolve. Through these mergers, galaxies grow, their histories rewritten with each new encounter. But the dance doesn't end there. Even after the galaxies have merged, their story continues. Supermassive black holes at their centers, once separate, now spiral toward each other, destined to collide in a final, dramatic act. This collision sends ripples through space-time itself, gravitational waves that echo across the universe, carrying with them the story of this cosmic dance. So, as we marvel at the beauty of galactic collisions, let's remember that these events are more than just spectacular shows. They're a vital part of the universe's story, shaping the galaxies we see today and laying the groundwork for the cosmos of tomorrow. And as we continue our journey, we'll explore how these collisions lead to even more extraordinary phenomena, from starburst galaxies to the birth of supermassive black holes. The dance of the galaxies is far from over. It's a story that's still unfolding, one collision at a time. Now, let's take a closer look at the different types of galactic collisions, each with its own unique characteristics and outcomes. Not all collisions are the same. Some are gentle brushes, while others are transformative encounters that reshape entire galaxies. Understanding these variations helps us appreciate the complexity of the cosmic dance. First, there are minor mergers. These occur when a large galaxy interacts with a much smaller one, often a dwarf galaxy. Imagine a giant absorbing a tiny companion. The smaller galaxy is gradually pulled apart, its stars and gas slowly incorporated into the larger galaxy. While this process might seem one-sided, it's far from insignificant. Minor mergers can subtly alter the structure of the larger galaxy, adding new stars and gas that fuel future star formation. They're like cosmic snacks, providing the larger galaxy with the materials it needs to grow and evolve. Next, we have major mergers, the most dramatic and transformative type of collision. This happens when two galaxies of similar size come together. Picture two spirals, each with its own swirling arms, slowly merging into one. The gravitational forces at play are immense, distorting both galaxies into chaotic, irregular shapes. Stars and gas are flung into long tidal tails, and the collision triggers intense bursts of star formation. Over time, the two galaxies lose their individual identities, blending into a single, often elliptical galaxy. Major mergers are like cosmic makeovers, completely reshaping the galaxies involved and leaving behind a new, unified structure. Then there are flybys, the gentlest form of interaction. In these encounters, two galaxies pass close to each other, but don't fully merge. Think of it as a cosmic near miss. While they don't collide head-on, their gravitational pull still leaves a mark. Flybys can stretch and distort the galaxies, creating bridges of stars and gas between them. These interactions might not lead to a full merger, but they can still influence the galaxy's shapes and trigger bursts of star formation. Flybys are like cosmic whispers, leaving subtle but lasting impressions. Each type of collision leaves its own unique imprint on the galaxies involved. Minor mergers add material and subtly alter structure. Major mergers create entirely new galaxies, and flybys leave behind delicate traces of their passage. Together, these interactions weave a complex tapestry of galactic evolution, shaping the universe as we know it. And as we continue our journey, we'll explore how these collisions lead to even more extraordinary phenomena, from the birth of starburst galaxies to the merging of supermassive black holes. The cosmic dance is as varied as it is beautiful, and each collision tells a new chapter in the story of the universe. Now, let's turn our gaze closer to home, to a cosmic event that will one day reshape our own galactic neighborhood. In about 4.5 billion years, the Milky Way and Andromeda galaxies are predicted to collide in one of the most spectacular mergers the universe has ever seen. This isn't just a distant possibility, it's a future written in the stars, and it will fundamentally alter the night sky as we know it. The Milky Way and Andromeda are currently racing toward each other at a speed of about 110 kilometers per second. Despite this incredible velocity, the vast distances between galaxies mean this collision will unfold over billions of years. When it finally happens, it won't be a sudden crash, but a slow, gravitational dance, much like the mergers we've already explored. The two spiral galaxies will first pass through each other, their gravitational forces pulling and distorting their shapes. Stars and gas will be flung into long, luminous tidal tails, creating a breathtaking display of cosmic chaos. But what does this mean for the stars within these galaxies? Surprisingly, most stars will survive the collision unscathed. The distances between stars are so vast that direct collisions are incredibly rare. Instead, the stars will be redistributed, their orbits reshaped by the gravitational forces at play. Over time, the Milky Way and Andromeda will lose their spiral structures, merging into a single elliptical galaxy. Scientists have even given this future galaxy a name, Milkomda. This merger will also have profound effects on the supermassive black holes at the centers of both galaxies. As the galaxies combine, their black holes will spiral toward each other, eventually merging into one even more massive black hole. This process will release tremendous amounts of energy, potentially triggering new waves of star formation and reshaping the galaxy's core. For us here on Earth, the night sky will transform dramatically. As the galaxies merge, the familiar band of the Milky Way will fade, replaced by a sky filled with the glowing remnants of two galaxies becoming one. It's a reminder that even our cosmic home is not permanent, but part of an ever-changing universe. While this collision might sound like a distant event, it's a powerful reminder of the dynamic nature of the cosmos. The Milky Way and Andromeda's future merger is just one example of how galactic cannibalism shapes the universe, creating new structures and opportunities for cosmic evolution. And as we continue our journey, we'll explore how these collisions give rise to even more extraordinary phenomena, from starburst galaxies to the ripples of space-time known as gravitational waves. The universe is a place of constant change, and every collision tells a story of destruction and creation. Now, let's dive deeper into the heart of this cosmic phenomenon, galactic cannibalism. At its core, galactic cannibalism is the process by which larger galaxies consume smaller ones, absorbing their stars, gas, and even dark matter. This isn't a violent, chaotic event like you might imagine. It's a slow, methodical process driven by gravity, the universe's ultimate sculptor. Over billions of years, the gravitational pull of a larger galaxy can draw in a smaller neighbor, gradually tearing it apart and incorporating its materials into its own structure. Imagine a cosmic dance where one partner is far more massive than the other. The smaller galaxy, unable to resist the pull, begins to lose its identity. Its stars are pulled into new orbits, its gas clouds are siphoned away, and even its dark matter becomes part of the larger galaxy's invisible framework. This process doesn't just destroy the smaller galaxy, it fuels the growth and evolution of the larger one. The absorbed stars and gas can trigger new waves of star formation, while the added dark matter strengthens the galaxy's gravitational grip, allowing it to grow even more massive over time. Galactic cannibalism plays a crucial role in shaping the universe as we know it. Without this process, galaxies would remain isolated islands, unable to grow or evolve. Instead, through these mergers, galaxies transform, becoming more complex and diverse. Some of the largest galaxies in the universe, like the giant ellipticals found at the centers of galaxy clusters, owe their size and structure to countless acts of galactic cannibalism over billions of years. This process also highlights the interconnectedness of the cosmos. No galaxy exists in isolation. Each one is part of a vast web of interactions, constantly influencing and being influenced by its neighbors. Galactic cannibalism is a reminder that the universe is a dynamic, ever-changing place, where destruction and creation go hand in hand. As we continue to explore the mysteries of the cosmos, we'll see how this process not only shapes individual galaxies, but also leaves its mark on the universe as a whole. Now, let's turn our attention to one of the most mysterious and powerful forces in the universe, dark matter. While we can't see it directly, dark matter plays a crucial role in galactic collisions, acting as the invisible hand that guides the fate of merging galaxies. Imagine dark matter as the hidden scaffolding of the cosmos, a vast network of gravitational influence that shapes how galaxies interact and evolve. When two galaxies collide, it's not just the stars and gas that are affected. Dark matter is at the heart of the action. Each galaxy is embedded in a massive halo of dark matter, which extends far beyond its visible boundaries. These halos are the true gravitational powerhouses, exerting a pull that dictates the motion of everything within and around them. As galaxies approach each other, their dark matter halos begin to interact, creating a complex gravitational dance that determines the outcome of the collision. One of the most fascinating aspects of dark matter is how it influences the speed and trajectory of merging galaxies. Because dark matter doesn't interact with light or other forms of electromagnetic radiation, it doesn't slow down or dissipate like gas or stars. Instead, it passes through itself and other matter, maintaining its gravitational grip. This means that during a collision, the dark matter halos can merge more smoothly than the visible components of the galaxies, often leading to a faster and more stable union. But dark matter's role doesn't end there. It also helps to stabilize the newly formed galaxy after the merger. The combined dark matter halo provides a gravitational framework that holds the galaxy together, preventing it from flying apart under the chaotic forces of the collision. This stabilizing effect is especially important in the formation of elliptical galaxies, which often result from major mergers. Without dark matter, these galaxies might not be able to maintain their structure, and the universe would look very different. Interestingly, dark matter also plays a part in triggering star formation during galactic collisions. As the gas clouds from the merging galaxies are compressed by the gravitational forces of the dark matter halos, they collapse and ignite new stars. This process can lead to the creation of starburst galaxies, which shine brightly with the light of countless newborn stars. In this way, dark matter not only shapes the structure of galaxies, but also fuels the birth of new stellar generations. The study of dark matter in galactic collisions has also provided scientists with valuable clues about its nature. By observing how dark matter behaves during these events, researchers can test theories about its properties and distribution. For example, the way dark matter halos interact during mergers supports the idea that dark matter is cold, meaning it moves relatively slowly compared to the speed of light. This has profound implications for our understanding of the universe's composition and evolution. As we continue to explore the mysteries of dark matter, one thing is clear: it is a key player in the cosmic drama of galactic collisions. Without its gravitational influence, the universe would lack the structure and diversity we see today. So, the next time you gaze at the night sky, remember that the galaxies above are not just shaped by the stars and gas we can see, but but also by the invisible hand of dark matter, quietly guiding their fate. Now, let's shift our focus to one of the most spectacular outcomes of galactic collisions: starburst galaxies. These cosmic wonders are born from the chaos of merging galaxies, where the intense gravitational forces and compressed gas clouds ignite a frenzy of star formation. Picture a galaxy ablaze with the light of millions of newborn stars, each one a testament to the transformative power of these cosmic encounters. When two galaxies collide, their gas clouds are pushed together, creating regions of incredibly high density. These dense pockets of gas become the perfect nurseries for new stars. As the clouds collapse under their own gravity, they heat up and ignite, giving birth to stars at a rate hundreds or even thousands of times faster than in a typical galaxy. This sudden burst of star formation is what gives starburst galaxies their name and their dazzling appearance. One of the most famous examples of a starburst galaxy is the antennae galaxies, a pair of colliding galaxies located about 45 million light-years away. Here, the collision has triggered a massive wave of star formation, lighting up the galaxies with the glow of countless young stars. The antennae galaxies serve as a stunning reminder of how galactic collisions can reshape the universe, turning chaos into creation. But what makes starburst galaxies so unique isn't just their brightness, it's the sheer scale of their star formation. In a starburst galaxy, stars are born in such large numbers that they can outshine the rest of the galaxy combined. These newborn stars are often massive and hot, burning brightly but living short lives. Their intense radiation can ionize the surrounding gas, creating glowing nebulae that add to the galaxy's brilliance. Interestingly, starburst galaxies don't just produce stars. They also play a crucial role in the evolution of galaxies. The rapid formation of stars consumes vast amounts of gas, depleting the galaxy's fuel reserves. Over time, this can slow down star formation, leading to a quieter, more stable galaxy. In this way, starburst galaxies represent a fleeting but transformative phase in a galaxy's life, a burst of activity that shapes its future. The study of starburst galaxies also provides valuable insights into the early universe. In the distant past, when galaxies were close together and collisions were more frequent, starburst galaxies were likely much more common. By observing these galaxies today, scientists can piece together the story of how galaxies evolved over billions of years, from their chaotic beginnings to the more orderly structures we see today. As we marvel at the beauty of starburst galaxies, we're reminded of the dynamic and ever-changing nature of the universe. These galaxies are not just cosmic accidents, they are the result of powerful forces at work, shaping the cosmos in ways that continue to inspire and amaze us. So, the next time you look up at the night sky, remember that even in the vastness of space, creation and destruction are intertwined, giving rise to some of the most breathtaking sights in the universe. Now, let's turn our attention to the colossal forces at the heart of galactic collisions: supermassive black holes. These enigmatic giants, lurking in the centers of galaxies, play a pivotal role in shaping the outcomes of galactic mergers. When two galaxies collide, their supermassive black holes are drawn together by gravity, setting the stage for a cosmic dance that can span millions or even billions of years. As galaxies merge, their supermassive black holes begin to orbit each other, gradually spiraling closer due to the loss of energy caused by gravitational interactions with stars and gas. This slow but inevitable process can lead to the formation of a binary black hole system, where two supermassive black holes are locked in a tight orbit. Over time, these black holes may eventually merge, creating an even more massive black hole. This merger releases an astonishing amount of energy, often in the form of gravitational waves, ripples in the fabric of space-time that can be detected by observatories here on Earth. One of the most fascinating aspects of this process is how supermassive black holes influence their surroundings during a merger. As they spiral closer, they can fling stars out of their orbits, creating chaotic and dynamic regions within the merging galaxies. The immense gravitational forces also heat up the surrounding gas, causing it to glow brightly and sometimes triggering bursts of star formation. In some cases, the interaction between the black holes can even produce powerful jets of particles that shoot out at nearly the speed of light, lighting up the cosmos with their brilliance. The merger of supermassive black holes is not just a spectacular event, it's also a key driver of galactic evolution. By merging, these black holes grow larger, and their gravitational influence shapes the structure of the newly formed galaxy. The energy released during the merger can also heat up or expel gas from the galaxy, affecting its ability to form new stars. In this way, supermassive black holes act as cosmic architects, sculpting the galaxies they inhabit. Interestingly, the study of supermassive black hole mergers provides a unique window into the early universe. In the distant past, when galaxies were smaller and more densely packed, such mergers were likely far more common. By observing these events today, scientists can gain insights into how galaxies and their central black holes have evolved over billions of years. This research also helps us understand the role of supermassive black holes in the growth and development of the universe's largest structures. As we explore the mysteries of supermassive black holes and their role in galactic mergers, we're reminded of the profound interconnectedness of the cosmos. These titanic events, though rare and distant, shape the universe in ways that ripple across space and time. They remind us that even in the vastness of space, the forces of gravity and the dance of celestial bodies continue to weave the intricate tapestry of the cosmos. And as we peer deeper into the universe, we uncover not just the secrets of black holes, but the story of how galaxies, and perhaps even life itself, came to be. Now, let's shift our gaze to one of the most extraordinary consequences of galactic collisions, the creation of gravitational waves. When supermassive black holes merge, they don't just reshape galaxies, they send ripples through the very fabric of spacetime itself. These ripples, known as gravitational waves, are like cosmic echoes, carrying information about the most violent and energetic events in the universe. Gravitational waves are produced when massive objects, like merging black holes, accelerate through space. As two supermassive black holes spiral closer and eventually collide, their immense gravitational fields distort spacetime, sending out waves that travel at the speed of light. These waves stretch and compress space as they pass through it, creating a subtle but detectable signal that can be observed billions of light years away. The detection of gravitational waves is a monumental achievement in modern astronomy. Using incredibly sensitive instruments like the Laser Interferometer, Gravitational Wave Observatory, or LIGO, scientists have been able to listen to the universe in a whole new way. When a gravitational wave passes through Earth, it causes tiny changes in the distance between mirrors in these detectors. Changes so small, they are measured in fractions of the width of an atom. By analyzing these signals, researchers can determine the masses of the merging black holes, their distance from Earth, and even the nature of the collision itself. What makes gravitational waves so fascinating is that they provide a completely different way of observing the universe. Unlike light, which can be blocked or distorted by dust and gas, gravitational waves travel unimpeded, offering a clear view of events that would otherwise remain hidden. This allows scientists to study phenomena like black hole mergers in unprecedented detail, revealing insights into the behavior of gravity under extreme conditions. The discovery of gravitational waves has also opened up new possibilities for understanding the universe's history. By detecting waves from ancient collisions, astronomers can peer back in time to when galaxies were young and the cosmos was a much more chaotic place. These observations help us piece together how supermassive black holes grew and how galaxies evolved over billions of years. As we continue to explore the universe through gravitational waves, we're not just uncovering the secrets of black holes, we're also testing the very foundations of physics. Each detection provides new data to refine our understanding of gravity, space-time, and the nature of the universe itself. And as our technology improves, we'll be able to detect even fainter waves, revealing more about the cosmic dance of galaxies and the hidden forces that shape our universe. Now, let's turn our attention to another breathtaking spectacle born from galactic collisions, tidal tails. These long, graceful streams of stars and gas are like cosmic brushstrokes, painted across the universe as galaxies interact and merge. When two galaxies come close enough, their gravitational forces tug and pull at each other, stretching out their outer regions into these luminous trails. It's a process that transforms chaos into beauty, leaving behind a signature of the collision that can last for billions of years. Tidal tails form because of the immense gravitational forces at play during a galactic encounter. As galaxies pass by or collide, their outer layers of stars, gas, and dust are pulled away from their original paths, creating these elongated structures. The material in these tails isn't just scattered randomly, it's shaped by the intricate dance of gravity, often forming arcs or spirals that stretch far beyond the main bodies of the galaxies. These tails can extend for hundreds of thousands of light years, making them some of the most striking features in the cosmos. What's truly fascinating is that tidal tails aren't just empty space. They're filled with stars, gas, and even the potential for new star formation. As the material is pulled away, it can become compressed, triggering the birth of new stars within the tails themselves. This means that even as galaxies are torn apart, they're also creating new structures and opportunities for cosmic evolution. It's a reminder that destruction and creation often go hand in hand in the universe. One of the most famous examples of tidal tails can be seen in the Antennae galaxies, a pair of colliding galaxies located about 45 million light years from Earth. Their long, intertwined tails are a testament to the power of gravity and the beauty of galactic interactions. These tails are not only visually stunning, but also scientifically valuable, offering clues about the dynamics of galaxy collisions and the distribution of matter in the universe. Tidal tails also serve as a kind of cosmic fossil record. By studying their shapes, lengths, and composition, astronomers can piece together the history of the collision that created them. They can determine how fast the galaxies were moving, the angle at which they collided, and even the amount of dark matter involved. This makes tidal tails not just beautiful to look at, but also incredibly useful for understanding the forces that shape our universe. As we marvel at these cosmic debris trails, we're reminded of the delicate balance between chaos and order in the universe. Tidal tails are a vivid reminder that even the most violent events can leave behind something extraordinary, something that tells a story of transformation and resilience. And as we continue to explore the cosmos, these stunning phenomena will undoubtedly reveal even more about the intricate dance of galaxies and the forces that bind them together. Now, let's shift our gaze to one of the rarest and most mesmerizing sights in the cosmos: ring galaxies. These celestial wonders are like cosmic bullseyes, their perfect circular shapes standing out against the vast backdrop of the universe. Unlike the chaotic swirls of spiral galaxies or the smooth ellipses of their elliptical counterparts, ring galaxies are defined by their striking, symmetrical rings of stars and gas. But how do these extraordinary structures come to be? The answer lies in a cosmic collision of a very specific kind. Ring galaxies form when a smaller galaxy passes directly through the center of a larger one. Imagine a stone dropped into a calm pond. The ripples that spread outward are similar to the effect created by this galactic encounter. As the smaller galaxy plunges through the heart of the larger one, its gravitational pull disrupts the orderly motion of stars and gas in the larger galaxy. This disruption sends shock waves rippling outward, compressing the gas and triggering a burst of star formation along the edges of the expanding ring. Over time, this ring of newly formed stars becomes the defining feature of the galaxy, creating a luminous halo that encircles its core. One of the most famous examples of a ring galaxy is Hoag's object, discovered by astronomer Arthur Hoag in 1950. Located about 600 million light-years from Earth, Hoag's object is a near-perfect ring of blue stars surrounding a golden core. Its symmetry and beauty have made it a favorite among astronomers and space enthusiasts alike. But Hoag's object is more than just a pretty face. It's a cosmic puzzle. Scientists are still working to understand the exact conditions that led to its formation, as well as why such ring galaxies are so rare in the universe. The rarity of ring galaxies is due to the precise conditions required for their formation. The smaller galaxy must pass almost perfectly through the center of the larger one, and the timing and angle of the collision must be just right. Even then, the ring structure is temporary on cosmic timescales, lasting only a few 100 million years before the galaxy begins to settle back into a more stable shape. This fleeting nature makes ring galaxies not only rare, but also valuable windows into the dynamics of galactic collisions. Studying ring galaxies provides astronomers with unique insights into how galaxies evolve and interact. The intense star formation in the rings offers clues about how gas is distributed and compressed during collisions, while the structure of the rings themselves can reveal details about the forces at play during the encounter. These galaxies also serve as natural laboratories for understanding the role of gravity in shaping the universe, as well as the processes that drive the birth and death of stars. As we marvel at these rare cosmic wonders, we're reminded of the delicate interplay of forces that shape the universe. Ring galaxies are a testament to the transformative power of galactic collisions, turning chaos into beauty and leaving behind structures that captivate our imagination. And as we continue to explore the cosmos, these rare and fleeting phenomena will undoubtedly reveal even more about the intricate dance of galaxies and the forces that bind them together. Now, let's turn our attention to the stars themselves, those countless points of light that fill the night sky. What happens to them when galaxies collide? It might seem like such a violent event would spell disaster for the stars caught in the chaos, but the reality is far more fascinating. In the grand dance of galactic mergers, most stars emerge unscathed, continuing to shine as they always have. But how is this possible? The key lies in the vast distances between stars. Even in the densest regions of a galaxy, stars are incredibly far apart. To put it into perspective, if our sun were the size of a grapefruit, the nearest star would be thousands of miles away. This immense spacing means that when galaxies collide, the likelihood of two stars actually hitting each other is astronomically low. Instead, stars glide past one another, their paths altered by gravity, but rarely intersecting. It's like two crowds of people walking through each other in an open field. Most individuals pass by without ever touching. However, this doesn't mean that stars are entirely unaffected. The gravitational forces at play during a galactic collision can pull stars out of their original orbits, sending them on new trajectories. Some stars may be flung outward, forming the long, sweeping tidal tails we've discussed earlier. Others might be drawn inward, contributing to the growing bulge at the center of the newly merging galaxy. Yet, despite these changes, the stars themselves remain intact, their fiery cores burning steadily as they navigate their new cosmic paths. What about the gas and dust that fill the space between stars? This is where the real action happens. Unlike stars, which are spread out, the gas and dust in galaxies are much more densely packed. When galaxies collide, these clouds of material slam into each other, compressing and heating up. This compression triggers bursts of star formation, creating new stars in the wake of the collision. So, while existing stars may survive the merger relatively unharmed, the collision often gives birth to a new generation of stars, adding fresh light to the cosmic tapestry. It's also worth noting that not all stars escape entirely unscathed. In rare cases, stars can be pulled into close encounters with one another, or even with supermassive black holes at the centers of galaxies. These extreme interactions can lead to dramatic outcomes, such as stars being torn apart or flung out of their galaxies entirely. But these events are the exception, not the rule. For the vast majority of stars, galactic collisions are more like a cosmic reshuffling than a destructive event. As we reflect on the fate of stars in these colossal mergers, we're reminded of the resilience and adaptability of the universe. Stars, born from the chaos of collapsing gas clouds, endure through the tumult of galactic collisions, continuing to light up the cosmos. And as galaxies merge and evolve, their stars carry on, bearing witness to the ever-changing dance of the universe. This resilience is a testament to the delicate balance of forces that govern the cosmos, where even the most violent events can lead to new beginnings. Now, let's take a step back and consider the bigger picture, how galactic cannibalism has shaped the universe over billions of years. This process isn't just a series of isolated events. It's a fundamental force that has driven the evolution of galaxies and, in turn, the cosmos itself. From the earliest moments of the universe to the present day, galactic cannibalism has played a crucial role in creating the rich diversity of galaxies we see today. In the early universe, galaxies were smaller and more numerous, forming in the dense regions of gas and dark matter that filled the cosmos. Over time, gravity began to pull these galaxies together, leading to collisions and mergers. As larger galaxies consumed smaller ones, they grew in size and mass, becoming the giant elliptical galaxies and massive spirals we observe today. This process of galactic cannibalism has been ongoing for billions of years, gradually transforming the universe from a sea of small, chaotic structures into the organized, diverse cosmic landscape we know. But galactic cannibalism isn't just about size, it's also about diversity. Each merger brings together different types of stars, gas, and dark matter, creating galaxies with unique characteristics. For example, when a spiral galaxy merges with another spiral, the result can be a new elliptical galaxy with its distinct shape and structure. These mergers also trigger bursts of star formation, adding new stars to the mix and altering the chemical composition of the galaxies involved. Over time, this has led to the incredible variety of galaxies we see, from the bright, star-filled spirals to the smooth, featureless ellipticals. Galactic cannibalism has also played a role in shaping the large-scale structure of the universe. As galaxies merge and grow, they form clusters and superclusters, vast collections of galaxies bound together by gravity. These structures are the building blocks of the cosmic web, the intricate network of filaments and voids that spans the universe. Without galactic cannibalism, the universe would look very different, smaller, less organized, and far less diverse. As we look out into the cosmos today, we're seeing the results of billions of years of galactic cannibalism. Every galaxy we observe, from the smallest dwarf to the largest elliptical, carries the marks of its history, a history shaped by collisions, mergers, and the relentless pull of gravity. And as galaxies continue to collide and merge, the universe will keep evolving, creating new structures and new wonders for future generations to discover. This ongoing process reminds us that the universe is not static. It's a dynamic, ever-changing place, where even the most violent events can lead to new forms of beauty and complexity. Galactic cannibalism is not just a destructive force, it's a creative one, driving the evolution of the cosmos and shaping the universe we call home. Now, let's turn our attention to how scientists unravel the mysteries of galactic cannibalism, not just by observing the cosmos, but by recreating it. To understand the intricate dance of colliding galaxies, researchers rely on the power of supercomputers, which allow them to simulate these cosmic events in extraordinary detail. These simulations are like time machines, giving us a front row seat to processes that unfold over billions of years, compressed into a matter of hours or days. At the heart of these simulations are complex mathematical models that account for gravity, gas dynamics, star formation, and even the elusive influence of dark matter. By inputting data about the size, shape, and composition of galaxies, scientists can predict how they will interact when they collide. The results are stunningly realistic, offering a glimpse into the chaotic yet beautiful processes that shape the universe. For instance, simulations have shown how tidal forces during a collision can stretch galaxies into long, flowing tails of stars and gas, or how the merging of supermassive black holes can send ripples through spacetime. But these simulations aren't just about creating pretty visuals. They're a crucial tool for testing theories and making predictions. For example, by running simulations of the Milky Way and Andromeda's future collision, scientists can estimate how the two galaxies will merge, what the resulting galaxy might look like, and how long the process will take. These insights help us understand not just individual collisions, but the broader patterns of galactic evolution. One of the most fascinating aspects of these simulations is their ability to reveal the role of dark matter. While we can't see dark matter directly, its gravitational effects are clearly visible in the way galaxies move and interact. Simulations show how dark matter halos, the invisible cocoons surrounding galaxies, play a key role in shaping the outcomes of collisions, often determining whether a merger will result in a spiral galaxy, an elliptical galaxy, or something entirely new. As technology advances, these simulations are becoming even more detailed and accurate. Supercomputers today can model galaxies with billions of stars, each following its own unique trajectory. This level of precision allows scientists to explore scenarios that were once unimaginable, from the formation of ring galaxies to the birth of starburst galaxies in the aftermath of a collision. Through these simulations, we're not just observing the universe, we're actively participating in its exploration. They provide a bridge between theory and observation, helping us piece together the story of how galaxies grow, evolve, and transform over time. And as we continue to refine these models, we'll uncover even more secrets about the cosmic dance of galactic cannibalism, bringing us closer to understanding the universe's grand design. Now, let's shift our gaze from the virtual cosmos of simulations to the real-world tools that allow us to witness galactic collisions as they unfold. Observing these cosmic events requires some of the most advanced technology ever created, from ground-based telescopes to space observatories that peer deep into the universe. These instruments are our eyes into the cosmos, capturing the light and energy emitted by colliding galaxies billions of light years away. Ground-based telescopes, like the Very Large Telescope in Chile or the Keck Observatory in Hawaii, play a crucial role in studying galactic collisions. These massive instruments use powerful mirrors to collect light from distant galaxies, revealing details about their structure, motion, and composition. By analyzing the light, astronomers can determine how fast galaxies are moving, whether they're approaching or receding from each other, and even the types of stars being born in the aftermath of a collision. However, Earth's atmosphere can distort the light from distant galaxies, making it harder to see fine details. That's where space telescopes come in. Space observatories like the Hubble Space Telescope and the James Webb Space Telescope have revolutionized our understanding of galactic collisions. Free from the interference of Earth's atmosphere, these telescopes can capture incredibly sharp images of colliding galaxies, revealing intricate details like tidal tails, star-forming regions, and even the faint glow of dark matter. Hubble, for instance, has provided some of the most iconic images of galactic collisions, showing galaxies twisted and stretched by gravitational forces in ways that seem almost otherworldly. But it's not just about taking pretty pictures. These telescopes also use specialized instruments to analyze the light from galaxies in different wavelengths, from visible light to infrared and ultraviolet. This multi-wavelength approach allows astronomers to see things that would otherwise remain hidden. For example, infrared observations from the James Webb Space Telescope can peer through clouds of dust to reveal the intense star formation triggered by galactic collisions, while ultraviolet observations can highlight the hottest, youngest stars. In addition to telescopes, astronomers also rely on radio observatories to study galactic collisions. These instruments detect radio waves emitted by gas clouds and supermassive black holes, providing insights into the dynamics of merging galaxies. By combining data from different types of telescopes, scientists can build a comprehensive picture of what happens when galaxies collide, from the initial encounter to the final merger. As technology continues to advance, so too does our ability to observe these cosmic events. New telescopes, both on the ground and in space, are being developed with even greater sensitivity and resolution. These next-generation instruments will allow us to study galactic collisions in unprecedented detail, uncovering new mysteries and deepening our understanding of the universe's grand design. Through the lens of these incredible tools, we're not just watching the universe, we're uncovering its secrets, one collision at a time. Now, let's journey back in time to the early universe, where the seeds of galactic cannibalism were first sown. Even in the cosmos' infancy, galaxies were already on the move, drawn together by gravity in a dance that would shape the universe as we know it today. Evidence of these ancient collisions comes from some of the most distant and faint objects we can observe, offering us a glimpse into a time when the universe was young and chaotic. One of the key pieces of evidence lies in the light from quasars, incredibly bright objects powered by supermassive black holes at the centers of galaxies. By studying the light from these quasars, astronomers have detected signs of galactic mergers billions of years ago. The light often shows distortions or absorption lines, indicating the presence of gas clouds and stars being pulled into the quasar's host galaxy, a telltale sign of galactic cannibalism at work. Another clue comes from the oldest galaxies we've observed, some of which date back to when the universe was just a few 100 million years old. These ancient galaxies often appear irregular and clumpy, with features that suggest they were formed through mergers. For example, some show elongated shapes or multiple cores, hinting at the collision and merging of smaller galaxies. These early mergers were crucial in building the first large galaxies, setting the stage for the cosmic structures we see today. Interestingly, the early universe was a much more crowded place than it is now. Galaxies were closer together, and collisions were far more frequent. This high rate of interaction meant that galactic cannibalism played a significant role in shaping the universe's evolution from the very beginning. As smaller galaxies merged, they formed larger ones, which in turn consumed even more of their neighbors. This process of growth through mergers has been ongoing for billions of years, leaving behind a trail of evidence in the form of massive elliptical galaxies and galaxy clusters. But how do we know all this? Much of our understanding comes from deep field observations, where telescopes like Hubble and James Webb stare at a single patch of sky for hours or even days, collecting light from the faintest and most distant objects. These observations reveal galaxies in various stages of merging, from close pairs to fully merged systems, providing a timeline of galactic cannibalism throughout cosmic history. As we peer deeper into the universe's past, we're not just uncovering the history of galactic cannibalism, we're also learning about the conditions that allowed galaxies to form and grow. The early universe was a place of intense activity, where gravity, dark matter, and gas worked together to create the first structures. By studying these ancient collisions, we gain insight into the forces that shape the cosmos and continue to shape it today. This journey into the early universe reminds us that galactic cannibalism isn't just a modern phenomenon, it's a process as old as the universe itself. And as we continue to explore, we'll uncover even more about how these cosmic collisions have shaped the story of the cosmos. Next, let's turn our attention to the role of gas in galactic mergers, a key ingredient that fuels the fires of star formation and drives the evolution of galaxies. Now, let's shift our focus to the unsung hero of galactic mergers, gas. While stars and dark matter often steal the spotlight, it's the gas within galaxies that plays a pivotal role in shaping the outcomes of these cosmic collisions. Gas is the lifeblood of star formation, and when galaxies collide, it becomes the fuel that ignites some of the most spectacular events in the universe. When two galaxies merge, their gas clouds are the first to interact. Unlike stars, which rarely collide due to the vast distances between them, gas clouds are much more likely to crash into one another. These collisions compress the gas, creating dense regions where gravity takes over. As the gas collapses under its own weight, it heats up, triggering the birth of new stars. This burst of star formation, often referred to as a starburst, can light up the merging galaxies, making them some of the brightest objects in the universe. But gas doesn't just fuel star formation, it also influences the dynamics of the merger itself. As gas clouds collide and compress, they can create shock waves that ripple through the galaxies, redistributing material and altering their shapes. This process can lead to the formation of new structures, such as spiral arms or rings, depending on the angle and speed of the collision. In some cases, the gas can even funnel toward the centers of the merging galaxies, feeding the supermassive black holes that reside there and causing them to flare up as active galactic nuclei. Interestingly, the amount of gas in a galaxy can determine the outcome of a merger. Galaxies rich in gas are more likely to experience intense star formation and dramatic transformations, while gas-poor galaxies may merge more quietly, with fewer new stars being born. This difference is one reason why we see such a wide variety of galaxy types in the universe today, each one shaped by the unique conditions of its past collisions. Gas also plays a key role in cooling the material within galaxies. As gas clouds collide and compress, they radiate energy, allowing the gas to cool and condense further. This cooling process is essential for star formation, as it enables the gas to reach the densities needed to ignite nuclear fusion. Without gas, galaxies would lack the raw material needed to create new stars, and the universe would be a much darker place. As we continue to study galactic mergers, the role of gas remains a central focus. By observing how gas behaves during these collisions, astronomers can better understand the processes that drive star formation and galaxy evolution. Telescopes like the Atacama Large Millimeter Array, or ALMA, have been instrumental in mapping the distribution of gas in merging galaxies, revealing intricate details about how these cosmic events unfold. So, the next time you gaze at a stunning image of colliding galaxies, remember that it's not just the stars and dark matter at work. It's the gas, quietly shaping the destiny of these cosmic giants. And as we explore further, we'll uncover even more about how this essential ingredient continues to shape the story of our universe. Next, let's delve into the mysterious connection between galactic cannibalism and dark energy, a force that's reshaping the cosmos on an even grander scale. Now, let's turn our attention to one of the most profound mysteries of the cosmos, the connection between galactic cannibalism and dark energy. While galactic mergers reshape individual galaxies, dark energy operates on a far grander scale, influencing the very fabric of the universe itself. This invisible force is responsible for the accelerated expansion of the cosmos, pushing galaxies apart at ever-increasing speeds. But how does this relate to the process of galaxies consuming one another? To understand this connection, we need to step back and consider the broader picture. Dark energy makes up roughly 68% of the universe's total energy content, and its effects are most noticeable on the largest scales. As the universe expands, galaxies are carried along with it, like leaves floating on a river. However, while dark energy drives galaxies apart on a cosmic scale, gravity, the force behind galactic cannibalism, pulls them together on a local scale. This creates a fascinating tug of war between these two opposing forces. Galactic cannibalism occurs when gravity overcomes the expansion driven by dark energy, allowing galaxies to collide and merge. These mergers are more likely to happen in regions where gravity is strong enough to counteract the influence of dark energy, such as within galaxy clusters. In these dense environments, galaxies are closer together, making it easier for gravity to pull them into collisions. Over time, these mergers contribute to the growth of massive galaxies, often at the expense of smaller ones. But dark energy isn't just a passive observer in this process. As the universe continues to expand, the distance between galaxies increases, making future mergers less likely. In the distant future, dark energy's influence will dominate, causing galaxies to drift apart so rapidly that even the strongest gravitational bonds won't be enough to bring them together. This means that galactic cannibalism, as we know it, is a phenomenon with an expiration date. The universe's current era, where galaxy collisions are still possible, is a fleeting chapter in the cosmic story. Interestingly, the interplay between dark energy and galactic cannibalism also offers clues about the universe's ultimate fate. Some theories suggest that dark energy's strength could change over time, potentially altering the balance between expansion and gravity. If dark energy weakens, gravity might regain the upper hand, leading to more frequent galactic mergers. On the other hand, if dark energy continues to dominate, the universe could end in a big freeze, where galaxies become so isolated that star formation ceases and the cosmos grows cold and dark. By studying galactic cannibalism, astronomers can gain insights into the behavior of dark energy and its impact on the universe's evolution. Observations of galaxy mergers, combined with measurements of the universe's expansion rate, help scientists refine their understanding of this mysterious force. Telescopes like the James Webb Space Telescope are providing unprecedented views of merging galaxies, allowing researchers to piece together how dark energy shapes the cosmos on both large and small scales. So, while galactic cannibalism may seem like a local phenomenon, it's deeply intertwined with the broader forces shaping the universe. From the birth of new stars in merging galaxies to the relentless push of dark energy, these processes remind us that the cosmos is a dynamic, ever-changing place. As we continue to explore these mysteries, we uncover not only the secrets of galaxies, but also the profound forces that govern the universe itself. Next, let's journey into the realm of galactic archaeology, where scientists trace the remnants of past mergers to uncover the history of our cosmic neighborhood. Now, let's delve into the fascinating field of galactic archaeology, where scientists act as cosmic detectives, piecing together the history of galaxies by studying the remnants of their past mergers. Just as archaeologists on Earth uncover ancient civilizations by examining artifacts and ruins, astronomers explore the universe's history by analyzing the stars, gas, and structures left behind after galaxies collide. Galactic archaeology begins with the idea that every galaxy carries a record of its past interactions. When galaxies merge, they leave behind telltale signs: streams of stars, distorted shapes, and even clusters of stars that don't quite belong. These remnants act like cosmic fingerprints, revealing the galaxy's history of collisions and mergers. By studying these features, scientists can reconstruct the events that shaped a galaxy over billions of years. One of the key tools in galactic archaeology is the study of stellar populations. Stars formed at different times and under different conditions carry unique chemical signatures. For example, older stars tend to have fewer heavy elements, while younger stars are richer in these materials. By mapping the distribution and composition of stars within a galaxy, astronomers can trace its evolutionary timeline, identifying when and how it merged with other galaxies. Another important clue comes from the motion of stars. When galaxies collide, their stars are flung into new orbits, creating intricate patterns that can be detected through careful observation. These patterns, known as tidal streams, are like cosmic breadcrumbs, leading scientists back to the moment of the merger. By analyzing these streams, researchers can determine the size, speed, and direction of the galaxies involved in the collision. Galactic archaeology also relies on advanced technology, such as powerful telescopes and computer simulations. Instruments like the James Webb Space Telescope allow astronomers to peer deep into the universe, capturing detailed images of distant galaxies and their remnants. Meanwhile, supercomputers simulate the complex dynamics of galactic mergers, helping scientists interpret the data and refine their understanding of these cosmic events. This field of study isn't just about uncovering the past. It also provides insights into the future. By understanding how galaxies have evolved through mergers, scientists can predict how our own Milky Way will change as it continues its journey through the cosmos. For instance, the upcoming collision with the Andromeda galaxy will leave its own mark, shaping the future of both galaxies in ways that galactic archaeologists of the distant future will one day study. Galactic archaeology reminds us that the universe is a dynamic, interconnected system where every collision and merger leaves a lasting legacy. As we uncover these cosmic histories, we gain a deeper appreciation for the forces that have shaped the galaxies we see today. Next, we'll explore how galactic cannibalism and galaxy collisions have captured the imagination of popular culture, inspiring stories and art that bring these cosmic events to life. Now, let's shift our gaze from the scientific realm to the world of storytelling, where galactic cannibalism and galaxy collisions have inspired countless works of art, literature, and film. These cosmic events, with their dramatic visuals and profound implications, have captured the imagination of creators and audiences alike, offering a blend of awe and wonder that transcends the boundaries of science. In movies, galactic collisions often serve as the backdrop for epic tales of survival, exploration, and transformation. Films like Interstellar and Star Trek have used the concept of merging galaxies to explore themes of time, space, and humanity's place in the universe. The sheer scale of these events provides a canvas for filmmakers to depict the grandeur of the cosmos, while also grounding their stories in relatable human emotions. Whether it's the struggle to find a new home or the awe of witnessing a cosmic spectacle, these films remind us of the fragility and resilience of life in the face of the universe's vastness. Books, too, have embraced the drama of galactic cannibalism. Science fiction authors like Isaac Asimov and Arthur C. Clarke have woven intricate narratives around the idea of galaxies colliding, using it as a metaphor for change, evolution, and the cyclical nature of existence. In their stories, the collision of galaxies often symbolizes the clash of civilizations, the merging of cultures, or the birth of something entirely new. These tales invite readers to ponder the deeper philosophical questions raised by such cosmic events, blending scientific accuracy with imaginative storytelling. Even in visual art, galactic collisions have left their mark. Artists have used the vibrant colors and dynamic shapes of merging galaxies to create stunning works that evoke both beauty and chaos. From paintings to digital art, these creations capture the essence of galactic cannibalism, transforming scientific phenomena into something that resonates on an emotional level. The swirling clouds of gas, the bursts of starlight, and the intricate dance of celestial bodies become metaphors for creation and destruction, inspiring viewers to reflect on the interconnectedness of all things. Popular culture's fascination with galactic cannibalism isn't just about spectacle, it's also a reflection of our innate curiosity about the universe. These depictions allow us to explore the mysteries of the cosmos in a way that feels personal and relatable, bridging the gap between the scientific and the imaginative. They remind us that the universe is not just a collection of stars and galaxies, but a source of endless inspiration and wonder. As we continue our journey through the mysteries of galactic cannibalism, we'll next turn our attention to the largest galaxies in the universe, many of which owe their immense size to a history of cosmic mergers. These galactic giants stand as testaments to the transformative power of collisions, shaping the universe in ways that continue to captivate both scientists and storytellers alike. Now, let's turn our attention to the titans of the cosmos, the largest galaxies in the universe. These colossal structures, often spanning hundreds of thousands of light years, are not born from a single event, but are the result of a long history of galactic cannibalism. Over billions of years, these galaxies have grown by consuming smaller neighbors, merging with others, and accumulating stars, gas, and dark matter in a process that reshapes their very essence. Elliptical galaxies, in particular, stand as some of the most striking examples of this cosmic growth. Unlike the spiral arms of galaxies like our Milky Way, elliptical galaxies appear as smooth, featureless spheres or ovals, their stars orbiting in random directions. This chaotic structure is a direct consequence of their violent past. When galaxies collide, the gravitational forces at play disrupt their orderly shapes, scattering stars into new orbits and blending their contents into a single, massive entity. Over time, these mergers erase the spiral patterns, leaving behind the dense, rounded forms we see today. But how do these mergers lead to such immense galaxies? The answer lies in the sheer scale of the collisions. When two large galaxies merge, their combined mass creates a gravitational pull strong enough to attract even more galaxies, setting off a chain reaction of mergers. This process, repeated over eons, results in galaxies that can contain trillions of stars, dwarfing even the largest spiral galaxies. Some of these giants, like the supergiant elliptical galaxy Messier 87, are so massive that they dominate their galactic clusters, exerting gravitational influence over hundreds of smaller galaxies. The role of dark matter in these mergers cannot be overstated. As galaxies collide, their dark matter halos the invisible, massive envelopes surrounding them, interact and merge, creating an even stronger gravitational field. This dark matter acts as a cosmic glue, binding the newly formed galaxy together and shaping its evolution. Without it, the stars and gas from the merging galaxies might simply drift apart, leaving behind a scattered, disorganized mess. Instead, dark matter ensures that the remnants of these collisions coalesce into a single, unified structure. Interestingly, the largest elliptical galaxies are often found at the centers of galaxy clusters, where the density of galaxies is highest. These regions are like cosmic crossroads, where galaxies frequently interact and merge. Over time, the central galaxy in a cluster can grow to immense proportions, consuming smaller galaxies and accumulating vast amounts of material. This process, known as hierarchical merging, is a key driver of galactic evolution, shaping the universe's largest structures. As we marvel at these galactic giants, it's worth noting that their size comes at a cost. The intense gravitational forces during mergers can strip away gas and dust, halting star formation and leaving the galaxy with an aging population of stars. This is why many elliptical galaxies appear red and dim, their once vibrant star-forming regions now quiet and still. Yet, even in their twilight years, these galaxies remain awe-inspiring, their sheer size and history a testament to the transformative power of galactic cannibalism. With this understanding of how the largest galaxies come to be, we can now explore how these cosmic titans influence their surroundings, shaping the very fabric of the universe. As we peer into the distant future of the cosmos, one thing becomes clear: galactic cannibalism will continue to play a defining role in shaping the universe. Over the next billions of years, galaxies will keep merging, growing larger and more massive as they consume their neighbors. This relentless process will gradually transform the cosmic landscape, leading to fewer but far more colossal galaxies scattered across the vast expanse of space. Imagine a universe where the Milky Way and Andromeda have long since merged, their spiral arms now a distant memory, replaced by a single, massive elliptical galaxy. This new galactic giant will continue to grow, pulling in smaller galaxies from its surroundings. Over time, even the most distant galaxies will feel the tug of gravity, drawn into a cosmic dance that ends in merger after merger. The result, a universe dominated by a handful of supermassive galaxies, each containing trillions of stars and spanning millions of light years. But what does this mean for the universe as a whole? As galaxies grow larger, the space between them will also expand, driven by the mysterious force of dark energy. This expansion will make it increasingly difficult for galaxies to interact, slowing the pace of mergers. Yet, even as the universe grows more diffuse, the largest galaxies will continue to exert their gravitational influence, pulling in whatever smaller galaxies remain within their reach. This ongoing process of galactic cannibalism will have profound implications for the universe's structure. Galaxy clusters, already home to some of the largest galaxies, will become even more concentrated, with their central galaxies growing to unimaginable sizes. These galactic titans will serve as the anchors of their clusters, their immense gravity shaping the movement of stars, gas, and even dark matter on a cosmic scale. Yet, as galaxies grow larger, they may also grow quieter. The intense gravitational forces during mergers can strip away the gas and dust needed to form new stars, leaving these galaxies with aging stellar populations. Over time, the vibrant star-forming regions we see today will fade, replaced by the dim glow of older stars. The universe, once teeming with the light of newborn stars, may grow darker and more subdued. Despite this, the beauty of galactic cannibalism lies in its transformative power. Through destruction and creation, it reshapes the universe, forging new structures from the remnants of the old. As we look to the future, we can only marvel at the intricate dance of gravity, dark matter, and dark energy that will continue to shape the cosmos, leaving us with a universe that is both awe-inspiring and profoundly different from the one we know today. Now, let's turn our gaze to an intriguing question. How do galactic collisions influence the search for extraterrestrial life? These cosmic events, while awe-inspiring, can have profound effects on the habitability of planets within merging galaxies. On one hand, the chaos of a galactic collision might seem like a death sentence for life. The intense gravitational forces, bursts of radiation, and violent interactions between stars and gas clouds could disrupt planetary systems, stripping away atmospheres or flinging planets into the void of space. For any life forms caught in the crossfire, the odds of survival might appear slim. Yet, galactic collisions also hold the potential to create new opportunities for life. The shockwaves from these mergers can compress gas clouds, triggering the birth of new stars and planetary systems. In these newly formed regions, planets with the right conditions for life could emerge, offering fresh habitats in the cosmos. Additionally, the mixing of materials from two galaxies could enrich the chemical composition of these systems, providing the building blocks necessary for life to take hold. Consider this: as galaxies merge, their supermassive black holes often spiral toward each other, eventually colliding in a cataclysmic event. While this might sound destructive, the energy released during such a merger could also heat surrounding gas, sparking the formation of new stars and planets. In some cases, these newly formed systems might lie in the Goldilocks zone of their stars, where conditions are just right for liquid water and, potentially, life. However, the search for life in a post-collision universe isn't without challenges. As galaxies grow larger through mergers, their central regions become dominated by older, redder stars, which emit less of the ultraviolet light needed to sustain life as we know it. Planets in these regions might find themselves in environments less conducive to life, with fewer resources and harsher conditions. Yet, even in these quieter corners of the universe, life might find a way to adapt, thriving in ways we have yet to imagine. Ultimately, galactic collisions remind us that the universe is a dynamic and ever-changing place. While they can destroy, they can also create, offering both challenges and opportunities for life to arise and evolve. As we continue our search for extraterrestrial life, these cosmic events serve as a reminder that the universe is full of surprises, and the potential for life may exist in the most unexpected places. Now, let's step back and consider the bigger picture. Galactic cannibalism, while it may sound destructive, is actually a cosmic balancing act, a dance of destruction and creation that shapes the very fabric of the universe. When galaxies collide, they don't just tear each other apart, they also give birth to something entirely new. It's a process that reminds us of the universe's incredible ability to transform chaos into order and destruction into opportunity. Think of it like this: when two galaxies merge, their stars, gas, and dark matter are thrown into a whirlwind of gravitational forces. Stars are flung out of their orbits, gas clouds are compressed, and entire systems are reshaped. Yet, out of this chaos, new stars are born and new galaxies emerge. The destruction of one structure often paves the way for the creation of another, in a cycle that has been repeating for billions of years. This balance between destruction and creation isn't just a cosmic coincidence, it's a fundamental part of how the universe evolves. Larger galaxies grow by consuming smaller ones, absorbing their resources and incorporating them into their own structures. But this process doesn't just lead to bigger galaxies, it also leads to more complex ones. The mixing of materials from different galaxies can create new chemical compositions, enriching the universe with the building blocks needed for stars, planets, and even life. At the same time, galactic cannibalism also plays a role in regulating the universe's growth. As galaxies merge and grow larger, they become more stable, with their gravitational pull shaping the surrounding space. This can slow down the rate of future collisions, creating a kind of cosmic equilibrium. It's a delicate balance, one that ensures the universe continues to evolve without spiraling into chaos. So, while the idea of galaxies devouring one another might seem violent, it's also a testament to the universe's resilience and creativity. Galactic cannibalism isn't just about destruction, it's about transformation. It's a reminder that even in the vastness of space, there's a rhythm to the chaos, a balance that keeps the universe moving forward. And as we continue to explore the mysteries of the cosmos, this balance serves as a powerful reminder of the beauty and complexity of the universe we call home. Now, let's take a moment to appreciate the sheer beauty of galactic collisions. These cosmic events are not just scientifically fascinating, they are also breathtakingly beautiful. When galaxies collide, they create some of the most stunning visual displays in the universe, filled with swirling colors, radiant light, and intricate patterns that seem almost otherworldly. Imagine two galaxies, each with billions of stars, slowly spiraling toward one another. As they merge, their gravitational forces pull and twist their structures, creating vast streams of stars and gas that stretch across the cosmos. These tidal tails, as they are called, can span hundreds of thousands of light years, forming delicate arcs and loops that glow with the light of countless stars. The collision compresses gas clouds, igniting bursts of star formation that light up the galaxies like cosmic fireworks. The result is a dazzling spectacle of blues, pinks, and golds, a celestial masterpiece painted across the darkness of space. Some of the most iconic images of galactic collisions come from telescopes like Hubble and James Webb. Take, for example, the antennae galaxies, a pair of colliding galaxies located about 60 million light-years away. Their long, sweeping tails of stars and gas resemble the antennae of an insect, giving them their name. The collision has triggered a frenzy of star formation, with bright blue clusters of young stars scattered throughout the galaxies. It's a snapshot of cosmic chaos and creativity, frozen in time. Another breathtaking example is the mice galaxies, two spiral galaxies in the process of merging. Their long, thin tails of stars and gas stretch out behind them like the tails of two mice, chasing each other through the void. The interaction has created a stunning interplay of light and shadow, with dark dust lanes weaving through the glowing starlight. These images are not just scientifically valuable, they are also works of art, capturing the imagination of anyone who sees them. The beauty of galactic collisions goes beyond their visual appeal. These events remind us of the dynamic, ever-changing nature of the universe, They show us that even in the vastness of space, there is a sense of motion, of transformation, of life. The colors and shapes we see in these images are not just random. They tell a story of gravity, time, and the forces that shape the cosmos. And it's not just astronomers who are captivated by these images. Artists, writers, and dreamers have long been inspired by the beauty of galactic collisions. They see in these cosmic events a reflection of the human experience, of creation, destruction, and the endless cycle of change. The images captured by telescopes have become symbols of the universe's grandeur, reminding us of our place in the vast tapestry of existence. So, the next time you see an image of colliding galaxies, take a moment to appreciate not just the science behind it, but the artistry as well. These cosmic collisions are more than just astronomical events. They are a reminder of the beauty and wonder that fills the universe, waiting for us to explore and admire. Now, let's turn our gaze backward in time to a universe far younger and more chaotic than the one we know today. Galactic cannibalism isn't just a dramatic cosmic event. It's also a powerful tool for scientists to explore the history of the universe. By studying how galaxies collide and merge, astronomers can uncover clues about how the cosmos evolved over billions of years, piecing together the story of its origins. When we observe galactic cannibalism, we're essentially looking at a snapshot of the universe's past. The light from these distant collisions has traveled for millions, sometimes billions, of years before reaching our telescopes. This means that when we see two galaxies merging, we're witnessing an event that happened long before Earth even existed. These ancient collisions provide a window into the early universe, revealing how galaxies formed, grew, and changed over time. One of the most fascinating aspects of galactic cannibalism is how it helps us understand the formation of the largest galaxies in the universe. Giant elliptical galaxies, for example, are often the result of multiple mergers over billions of years. By studying these galaxies, scientists can trace their history, seeing how smaller galaxies were absorbed and transformed into the massive structures we observe today. It's like reading a cosmic history book, with each merger adding a new chapter to the story. But galactic cannibalism doesn't just tell us about the past. It also helps us understand the forces that shape the universe. Dark matter, for instance, plays a crucial role in these collisions. Its gravitational pull guides the motion of galaxies, influencing how they merge and interact. By studying the remnants of past mergers, scientists can map the distribution of dark matter, shedding light on this mysterious substance that makes up most of the universe's mass. Another key insight comes from the stars and gas left behind after a collision. Tidal tails, those long streams of stars and gas pulled out during a merger, can persist for billions of years. These remnants act like cosmic fossils, preserving the conditions of the early universe. By analyzing their composition and structure, astronomers can learn about the environment in which these galaxies formed, including the density of gas and the rate of star formation at the time. Galactic cannibalism also offers clues about the evolution of supermassive black holes. When galaxies merge, their central black holes often spiral toward each other, eventually merging as well. These events release tremendous amounts of energy and can trigger bursts of star formation. By studying the remnants of these collisions, scientists can better understand how black holes grow and influence their surroundings, shaping the galaxies we see today. In a way, galactic cannibalism is like a time machine, allowing us to peer into the universe's distant past. Each collision, each merger, tells a story of how the cosmos has changed over billions of years. And as we continue to study these events, we gain a deeper understanding of the forces that have shaped the universe and our place within it. So, the next time you see an image of colliding galaxies, remember, you're not just looking at a beautiful cosmic event. You're witnessing a piece of the universe's history, a glimpse into the origins of everything we know. As we look ahead, the future of astronomy holds incredible promise for unraveling the mysteries of galactic cannibalism. With each passing decade, advancements in technology are equipping scientists with tools that were once the stuff of science fiction. Telescopes like the James Webb Space Telescope, with its unparalleled ability to peer into the infrared spectrum, are already revealing details of galactic collisions that were previously hidden from view. These observations are not just about capturing stunning images, they're about decoding the intricate processes that drive galactic evolution. One of the most exciting developments is the rise of supercomputers capable of simulating galactic mergers with unprecedented accuracy. These simulations allow astronomers to recreate the conditions of the early universe, testing theories about how galaxies collide, merge, and evolve. By comparing these models to real-world observations, scientists can refine their understanding of the forces at play, from the role of dark matter to the behavior of supermassive black holes during collisions. It's like having a cosmic laboratory where we can experiment with the building blocks of the universe. Another groundbreaking area is the study of gravitational waves, ripples in space-time caused by massive cosmic events. As detectors like LIGO and Virgo become more sensitive, they're opening a new window into the universe, allowing us to listen to the mergers of supermassive black holes. These events, often the result of galactic collisions, provide a unique opportunity to study the dynamics of these powerful interactions. By combining gravitational wave data with traditional observations, astronomers can piece together a more complete picture of how galaxies evolve. The next generation of ground-based telescopes, such as the Extremely Large Telescope, will also play a crucial role. With mirrors spanning tens of meters, these instruments will capture sharper and more detailed images of colliding galaxies, revealing structures like tidal tails and star-forming regions in exquisite detail. This level of precision will help scientists understand how gas and stars are redistributed during mergers, shedding light on the processes that shape galaxies over time. But it's not just about bigger and better telescopes. Advances in data analysis and artificial intelligence are revolutionizing how we process the vast amounts of information collected by these instruments. Machine learning algorithms can sift through data to identify patterns and anomalies, helping astronomers uncover new insights about galactic cannibalism that might otherwise go unnoticed. This synergy between technology and human curiosity is driving discoveries at an unprecedented pace. As we continue to explore the cosmos, one thing is clear: the study of galactic cannibalism is far from over. Each new discovery raises new questions, pushing the boundaries of our knowledge and inspiring the next generation of astronomers. The future of astronomy is not just about understanding the universe. It's about uncovering the stories written in the stars, stories that reveal how galaxies, including our own, came to be. And as we unlock these secrets, we'll gain a deeper appreciation for the dynamic, ever-changing nature of the cosmos. As we bring our cosmic journey to a close, let's reflect on the awe-inspiring phenomenon of galactic cannibalism and the mysteries that continue to captivate scientists and stargazers alike. Throughout this exploration, we've uncovered how galaxies, those vast islands of stars, gas, and dark matter, collide and merge in a slow, gravitational dance that reshapes the universe. From the birth of galaxies in the early universe to the dramatic mergers that create starburst galaxies and supermassive black holes, we've seen how these events are not just destructive, but also profoundly creative, giving rise to new structures and cosmic wonders. Yet, despite the incredible progress in our understanding, galactic cannibalism remains a cosmic mystery filled with unanswered questions. For instance, how exactly does dark matter influence the outcomes of these collisions? While we know it plays a crucial role in shaping galaxies, its invisible nature makes it difficult to study directly. Similarly, the behavior of supermassive black holes during mergers is still not fully understood. What happens when these colossal objects spiral toward each other, and how do they eventually merge? The detection of gravitational waves has opened a new window into these events, but much remains to be discovered. Another lingering question is how galactic cannibalism has shaped the universe over billions of years. While we've observed evidence of past mergers in the structures of galaxies today, piecing together the full history of these cosmic encounters is like trying to solve a puzzle with missing pieces. How many galaxies have been consumed over time, and how has this process contributed to the diversity of galaxies we see today? These are questions that continue to drive astronomers to push the boundaries of technology and knowledge. And then there's the future. What will the universe look like billions of years from now as galactic cannibalism continues to unfold? Will the Milky Way and Andromeda, after their predicted collision, form a new, even larger galaxy? And what role will dark energy, the mysterious force driving the universe's accelerated expansion, play in this cosmic drama? These are questions that remind us of how much we still have to learn about the universe and our place within it. Galactic cannibalism is more than just a scientific curiosity. It's a window into the dynamic, ever-changing nature of the cosmos. It challenges us to think beyond our own galaxy and consider the vast, interconnected web of galaxies that make up the universe. As we continue to explore these mysteries, we're not just uncovering the secrets of the stars, we're gaining a deeper understanding of the forces that have shaped the universe since its birth. So, as we conclude this journey, let's marvel at the beauty and complexity of galactic cannibalism. It's a reminder that the universe is a place of endless wonder, where destruction and creation are intertwined, and where every discovery brings us closer to understanding the grand story of existence. Thank you for joining us on this cosmic adventure. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest explorations of the universe. Until next time, keep looking up. The stars have so much more to reveal. As we draw the curtains on this cosmic exploration, let's take a moment to reflect on the profound implications of galactic cannibalism. This phenomenon isn't just a distant spectacle happening billions of light years away. It's a fundamental process that has shaped the universe we see today. From the birth of galaxies to the dramatic collisions that forge new cosmic structures, galactic cannibalism reminds us that the universe is in a constant state of transformation, where destruction and creation are two sides of the same coin. Think about it. Every time galaxies collide, they rewrite the story of the cosmos. Stars are born, black holes merge, and tidal tales stretch across the void, painting the universe with breathtaking beauty. These events are not just scientific curiosities, they are windows into the very fabric of existence. They challenge us to think beyond our own galaxy and consider the interconnectedness of all things in the vast cosmic web. And yet, for all we've learned, the universe still holds countless mysteries. What drives the intricate dance of galaxies? How does dark matter shape their fate? What will the universe look like in the distant future as galactic cannibalism continues to unfold? These questions remind us that the cosmos is a place of endless wonder, where every discovery leads to new questions and deeper understanding. So, as we conclude this journey, let's carry with us a sense of awe and curiosity. The universe is vast, complex, and full of surprises, and galactic cannibalism is just one of the many stories it has to tell. Whether you're a seasoned stargazer or someone just beginning to explore the wonders of space, there's always more to discover, more to marvel at, and more to inspire us. Thank you for joining us on this cosmic adventure. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest explorations of the universe. Until next time, keep looking up. The stars have so much more to reveal. you.